Mechanical energy is actually pretty straightforward. It's just your potential energy plus your kinetic energy. That's it. Now let's say that you had a monkey throw poop at you, okay? Let's say the poop had a mass of 0.1 kilograms. It had a velocity of 4 meters per second. And it was, let's say, a meter off the ground. Let's find the mechanical energy of that. First, we're going to find the potential energy. So potential energy is mass times gravity times height. So potential energy is 0.1, g is 9.8, we're on Earth, height is 1. So the potential energy of the poop as it flies along here is 0.98 joules. Let's go after the kinetic. The kinetic energy is mv squared divided by 2. So kinetic energy is 0.1, velocity is 4 squared divided by 2, and math, we get 0.8 joules. So if we want to get the mechanical energy is potential plus kinetic. So mechanical energy is 0.98 plus 0.8 equals 1.78 joules. Yahtzee. You'll sometimes hear us talk about whether mechanical energy is conserved or not. Conserved is just a fancy word for saying doesn't change. Okay. So for example, if you were on a sled and at the top of the hill you had a potential energy of, let's say, 10 joules, apparently you're very tiny, and your kinetic energy was 0, and then partway down you now had a potential energy of 5 joules and a kinetic energy of 5 joules, we would say that your mechanical energy is conserved because your mechanical energy up here was 10 and your mechanical energy down here was still 10. In real life, that does not happen. If this were to happen, the second law of thermodynamics would be violated and the universe would fall into a chaotic mass of darkness. What really happens in real life is a little bit of the energy is what we would say in layman's terms is lost. It's not really lost though, okay? So in real life, you wouldn't get something going 10 at the top and 10 down here. We might have 10 up here and maybe 8 down here. Where did that energy go? Well, some of it is lost in the form of sound and heat, which we're going to refer to in this class as thermal energy. Okay, whenever you have thermal energy, the mechanical energy is not conserved. Some of it is lost. We can't say that it's gone forever. Where does that thermal energy go? Well, it actually heats up the air around it. It moves on. We don't really talk about energy ever disappearing because that violates one of the key principles of the universe, which is called the law of conservation of energy. Which states energy cannot be created or destroyed. It can change forms. So while you can lose mechanical energy going from one thing to another, everything you lose has to turn into thermal energy. You can't lose the total energy of the system at all, except for some small forms, which we talk about later on. That's a caveat.